Now let us move on to the one more important and slightly tricky experiment where we have to find the focal length of a convex lens. Now in this experiment the rough estimate of the focal length is compulsory, do not skip that, and in this part what you have to do, you have to take a stand and a white screen like this and adjust the lens such that you get a clear focused image of a distant building that you can see from your window of your college or a very distant point which is located outside. Now once you have done it, use a scale and measure the distance between these 2 points. Remember, when measuring the distance you are trying to measure the distance from the screen and to the middle of the lens. So that is very important. Do not take the middle of this screen, you have to start measuring from this surface and till the middle of this frame. Now when you are measuring rough estimate, you should align the scale and take a measurement which is coming out to be around 10 centimeter in this case. Now use this value when you are performing the experiment using the optical bench. So now once you are done with the rough experiment, try to find the focal length from the 2f positions. For example, in our rough experiment measurement we got a rough estimated focal length to be 10 centimeter. So we will start with 20 centimeter. So 20 centimeter will be our object pin and we will fix our image pin also around 20 centimeter. That is a back method, obviously I am teaching you how to trick. So first measurement should be around 20 centimeter, right, 20 centimeter from the lens, 20 centimeter from the lens in this side as well. So because we know if the distance is 2f, you get exactly image formed at 2f. Now if this is object pin, how to observe the image, very interesting. So when you observe from this side of the lens, you will see an image forming exactly on top of this. Now align your image pin so that the height should be same, also the alignment of the pins should also be same. Now once you get the image on top of this like this, you have to make sure there is no parallax. Now how to remove the parallax or how to know that there is a parallax? So parallax is when you move your head like this, when you move your head by closing one eye, and if the image pin and object pin both are moving together. So if they are stick together like this, then we will say there is no parallax. But if one pin is moving on the other side, another pin is moving on the opposite side, then there is a parallax. Now based on where your image pin is, suppose it is here or here, so you will get a different parallax and you have to adjust it so that you get exactly perfect zero parallax. Now zero parallax is easy for the first reading, that is 2f. Now you have to adjust the distance slightly, you have to decrease it, but remember that you should not go below the rough estimated focal length. Suppose your rough estimated focal length is 15 and you are starting with 30 centimeter, you can go higher than 30 centimeter, but it should not go below 15 centimeter, otherwise you will not get a real image, you will get a virtual image, right. In this experiment you have to take 5 different measurements because it is a plotting graph experiment, you have to plot u versus v. So to plot the graph you have to take 5 different u's and corresponding 5 different v's. Now if you know the rough estimated value of focal length, which is around 10 centimeter in this case, you can back calculate and find the u's for different v's and almost try to adjust it, but remember that you have to sign the readings with the invigilator. At least one of the readings should be signed by the invigilator. Make sure you are signing up the 2f, which is very easy to find, right. And with these tips and tricks, all the best for your upcoming practical exam. I will be back with more experiment.